solve the quadratic equation. This solution you know very well. Yeah? So what you get is, maybe I create this, is what is, so T is, I write it this way, minus Q plus minus Q times 7 1 times. Then I can rewrite it in the following way. 2Q plus minus that's okay? Okay, so maybe sorry, yeah, I just erase it. Yeah, but anyway, we really need the condition x is u plus v, and uv should be minus what? Px. It's okay. Okay, that's very important. Okay, and Q and VQ are solution of this quadratic equation. And if you look at this expression, U and V are symmetric. So you can choose. For example, you can assume that U cube equal to 2Q plus. So simplified notation, I use the following notation. And VQ is minus. Then, what is the solution? X. Original. You just take the cubic root of that's okay?
That's a minus.
Oh, sorry, yes. So that's okay? And then, actually, Bombelli found that not enough. Or in other way, just apply this formula for the equation what I wrote at the beginning. 15x plus what is the number? X plus 4. So in this case, the P is minus 15 and Q is minus 4. Just apply this. And we already know that 4 is the solution of this equation. So that means that 4 should be written in this way. Then how do you get it? 4, 4. And then what is it? 2 times, what is it? This is 2, and P is minus 15. So this is 3 times. So this is 4 minus 125. So this is minus 1. Created in this way. Okay. And then that's Bombelli completely puzzled. What happens? Because this is 4 is the real number. But here you have a complex number of of course, you can write that this is I is imaginary unit. So people are a little bit afraid using the complex numbers because of such puzzling things. And later, the many mathematicians found more and more interesting or strange phenomena. So the many cubic equation has three good solutions. Many cubic equation. There are many cubic equations whose solutions are all reals. But if you apply this method, then all solutions are always expressed by using the imaginary numbers. So people are really puzzled. Why? Because you have real cubic equations and solutions are all real. So we hope that the sort of the expression of the root or solution should be, everything should be real. And many mathematicians really tried to solve this problem, and later it turns out it's impossible. Even if everything is real, you have to always introduce imaginary numbers to write down the formula. So this is a very strange thing, and later it gives the sort of the motivation to develop further the equations. But anyway, how should I go? It's a sort of a turning point, and okay, and maybe that's a one hint, or maybe sort of exercise. So please justify this one. Okay. So this is exercise. Exercise. Justify. What's the problem? What's the problem is for the real numbers, you have only one cubic root. But if you consider the complex numbers, you can always find three different cubic roots. So in a sense, the way of writing this is not precise. It's a quite imprecise way of the expression, because you have to point it out which cubic root you take.
Maybe the choice doesn't really matter.
Does matter, actually.
Doesn't matter.
Does matter. If you choose a different one, then you get a different solutions. So what I'll say is the following.
So not all the 9 combinatories give the precise 3 answers.
Yes, there is actually the one condition. There are 3 ways of choosing this cubic root, but you have always have a condition, this condition. This is an imposed condition. So you cannot choose arbitrarily. That's one point. And another point is, what is a complex number whose cube is 1? No, sorry. Then of course, you can easily take the factorization. So the of course one simple solution is 1, but the other solution is given by this quadratic equation, which is given by -1 plus minus. So 3i. Okay. So for example, I choose omega is 2 minus 1 plus 2i. Okay, I is just imaginary unit. Then you can always omega cube is 1. Then what is the solution here? So I write that u plus v And then this is one solution. The other solution is omega plus omega v. But of course, there's one condition. uv should be satisfied always this condition. Yeah. This is very important. Maybe later you can realize what I mean, but somehow this gives you three solutions. So that means that if you choose another cubic root in this precise way, suitable way, you get another solution of this equation. And that's also very easy to solve because since you know that one solution is.
And still another problem. The whole method seems out of blue.
Well, and then what is the rest? I hope that China. No. I think that China has a long tradition of the. So. Oh no. So. No, what is wrong? It's correct. This is wrong. It's okay. This is a Chinese method. The Western people say the Hona's method, but it's not true. Hona they were very late. So that another solution is what is solution? Another solution is 2 plus minus 2 plus minus 2 minus 2 3. Yeah. So that's also this number can also express by using a suitable cubic root of this complex numbers. So please find what cubic root you can choose. But of course, to explain what kind of the cubic root, you really need the theory of the complex numbers. So the complex numbers appeared already in the 16th century in Italy. The many mathematicians really hesitated to use it. It sounds very strange. So already the imaginary number means that something. But today that you can define the complex number several ways, but the simplest way is just introduce I is a number such that it is minus 1, and then the complex number is just A plus BI. And A and B are real number. I use this notation L is a real number. And just, of course, you have to define that these two numbers are the same if and only if A prime is equal and B and B prime is equal. Such things, usual things you, of course, need. Then you can show that. You can introduce addition and subtraction and multiplication and even division if it's not 0. Okay, but complex number has a very interesting property. If you light expression